Chapter 2, Structure of Atom Revision. The word atom has been derived from Greek word atomio, which means uncuttable or non-divisible. J.J. Thomson in 1898 proposed that an atom possesses a spherical shape, radius approx 10 to the power minus 10 meter, in which the positive charge is uniformly distributed. Electrons are embedded into it in such a manner as to give the most stable electrostatic arrangement. Many different names are given to this model, for example, plum pudding, raisin pudding, or watermelon. Rutherford's nuclear model of atom. Most of the space in the atom is empty, as most of the alpha particles pass through the foil undeflected. A few positively charged alpha particles were deflected. The deflection must be due to enormous repulsive force, showing that the positive charge of the atom is not spread throughout the atom as Thomson had presumed. The positive charge has to be centered in a very small volume that repels and deflected the positively charged alpha particles. Calculations by Rutherford showed that the volume occupied by the nucleus is negligibly small as compared to the total volume of the atom. So that volume occupied by the nucleus is negligibly small as compared to the total volume of atom. The radius of the atom is 10 to the power minus 10 meter, while that of nucleus is 10 to the power minus 15 meter. On the basis of above observation and conclusion, Rutherford proposed the nuclear model of atom after the discovery of protons. According to this model, the positive charged and most of the mass of the atom was densely concentrated in an extremely small region. This very small portion of the atom was called nucleus by Rutherford. The nucleus is surrounded by electrons that move around the nucleus with a very high speed in circular paths called orbits. Thus, Rutherford's model of atom resembles the solar system, in which the nucleus plays the role of sun and electrons that of revolving planets. Electrons and a nucleus are held together by electrostatic forces of attraction. The number of protons present in nucleus is equal to atomic number Z. The nucleus is equal to atomic number Z, that is, atomic number Z is equal to number of protons in nucleus of atom is equal to number of electrons in a neutral atom. Protons and neutrons present in a nucleus are collectively known as nucleons. Total number of nucleons is termed as mass number of atom, as mass number is equal to number of protons plus number of neutrons. Isobars are the atoms with same mass number but different atomic number. For example, C614 and N714 on the other hand, atoms with identical atomic number but different atomic mass number are known as isotopes. Drawbacks of Rutherford model. According to the electromagnetic theory of Maxwell, charged particles, when accelerated, should emit electromagnetic radiation. This feature doesn't exist for planets since they are uncharged. Therefore, an electron in an orbit will emit radiation. The energy carried by radiation comes from electronic motion. The orbit will thus continue to shrink. Calculations show that it should take an electron only 10 to the power minus 8 seconds to spiral into nucleus, but this doesn't happen. Thus, the Rutherford model couldn't explain the stability of an atom. Frequency v, wavelength lambda, and velocity of light c are related by the equation c is equal to v lambda. Other commonly used quantity, especially in spectroscopy, is the wave number v dash. It is defined as the number of wavelengths per unit length. Its unit is a reciprocal of wavelength unit, that is meter minus 1. H. Hertz performed a very interesting experiment in which electrons or electric current were ejected from certain metals, for example potassium, rubidium, cesium, etc., were exposed to a beam of light. Phenomena is called photoelectric effect. For photoelectric effect, HV is equal to HV0 plus half mv square. Planck's quantum theory. The energy is radiated or absorbed by a body not continuously but discontinuously in form of small packets. Each packet is called quantum. In case of light, the quantum is called photon. The energy of quantum is directly proportional to the frequency V of the radiation. E is directly proportional to VE is equal to HV, where H is Planck's constant. Its value is 6.625 into 10 to the power minus 34 joule second. Uh, The spectrum of radiation emitted by a substance that has absorbed energy is called an emission spectrum. Atoms, molecules, ions that have absorbed radiation are said to be excited to produce an emission spectrum. Energy is supplied to a sample by heating it or irradiating it, and the wavelength or frequency of the radiation emitted as the sample gives up the absorbed energy is recorded. An absorption spectrum is like the photographic negative of an emission spectrum. A continuum of radiation is passed through a sample which absorbs radiation of certain wavelength. Line spectrum of hydrogen. When an electric discharge is passed through gaseous hydrogen, the H2 molecules dissociate and the energetically excited hydrogen atoms produced emit electromagnetic radiation of discrete frequencies. The hydrogen spectrum consists of several series of lines named after their discoverers. Lyman 1. Ultraviolet region. Lyman 1 to 3. Ultraviolet. Balmer 234 visible. Persian 345 infrared. Bracket 456 infrared. Fun 567 infrared. The Swedish spectroscopist Jöns Rydberg noted that all series of lines in the hydrogen spectrum could be described by following expression. V bar is equal to 109,677 multiplied by 1 by n2 n1 square minus 1 by n2 square centimeter minus 1. Bohr's model of hydrogen for hydrogen atom. The electron in the hydrogen atom can move around the nucleus in a circular path of fixed radius and energy. The energy in the hydrogen atom can move around the nucleus in a circular path of fixed radius and energy. These paths are called orbits, stationary states, or allowed energy states. These orbits are arranged concentrically around the nucleus. An electron can move only in those orbits for which its angular momentum is integral multiple of h by 2 pi. That is why only certain fixed orbits are allowed. The angular momentum of an electron in a given stationary state can be expressed as an equation MEVR is equal to n into h by 2 pi, where n is equal to 1 to 3, etc. 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 Energy of an electron in the orbit does not change with time. However, the electron will move from a lower stationary state to a higher stationary state when required amount of energy is absorbed by the electron, or energy is emitted when electron moves from higher stationary state to lower stationary state. The energy change doesn't take place in a continuous manner. Frequency of radiation absorbed or emitted when transition occurs between two stationary states that differ in energy by delta E is given by V is equal to delta E by H, which is equal to E2 minus E1 by H. Bohr's theory can also be applied to the ions containing only one electron, similar to that present in hydrogen atom, for example, He plus, Li2 plus, Be3 plus, and so on. The energies of the stationary states associated with these kinds of ions, also known as hydrogen-like species, are given by this. En is equal to minus 2.18 into 10 to the power minus 18 multiplied by z square by n square joule, and the radii by the expression Rn is equal to 52.9 in n square by z pm. Limitations of Bohr's model. It fails to account for the finer details, doublet, that is, too closely spaced lines, of the hydrogen atom spectrum observed by using sophisticated spectroscopic techniques. This model is also unable to explain the spectrum of atoms other than hydrogen. For example, helium atom, which possess only two electrons. Further, Bohr's theory was also unable to explain the splitting of spectral lines in presence of magnetic field B manifest or an electric field Stark effect. Dual behavior of matter. French physicist de Broglie in 1924 proposed the matter that matter-like radiation should also exhibit dual behavior, that is, both particle and wave-like properties. The de Broglie relation. De Broglie relation states that the wavelength associated with a moving object or an electron is inversely proportional to the momentum of the particle. Lambda is equal to h by mv is equal to h by p, as where p is momentum of particles, which is equal to mv. Heisenberg uncertainty principle. It is not possible to determine the position and velocity simultaneously for a subatomic particle like electron at any given instant to an arbitrary degree of precision. Consequently, it is not possible to talk of path of the electron in which it moves if delta x is uncertainty in position and delta p is uncertainty in momentum, then delta x delta p is greater than or equal to h by 4 pi. Orbital. It's a region or space where there is maximum probability of getting electrons. Probability of getting electrons. Quantum numbers. They are used to get complete information about electron, that is location, energy, spin, etc. These quantum numbers also help to designate the electron present in an orbital. Principal quantum number. It specifies the location and energy of an electron. It is measure of the effective volume of the electron cloud. It is denoted by n. Its possible values are 1, 2, 3, 4 and so on. Angular momentum quantum number. It is also called azimuthal quantum number. It determines the shape of the orbital. It is denoted by small l. The permitted values of L are 0, 1, 2, etc. up to n minus 1. For a given value of n, L is equal to 0 to n minus 1. Example, if value of n is 4, L can have value 0, 1 to 3. It determines angular momentum mvr, which is equal to under root L into L plus 1 h by 2 pi. Magnetic quantum number. It is denoted by small m and its value depends on value of small l. Since magnetism is due to angular momentum, it determines the magnetic orientation of an orbital, that is the direction of orbital relative to magnetic field. It determines the magnetic orientation of an orbital, that is the direction of orbital relative to magnetic field in which it is placed. Its permitted values are minus L to plus L including 0. Example, when L is equal to 1, then M is equal to minus 1, 0 and plus 1. It has total number of values equal to 2L plus 1. Spin quantum number. It indicates the direction in which electron revolves. Spin is magnetic property and is also quantized. It has two permitted values, plus half and minus half or minus half. The spin angular momentum of an electron is constant and can't be changed. N plus L rule. The relative order of energies of various subshells in a multi-electron atom can be predicted with the help of N plus L rule, also called Bohr-Bury rule. According to this rule, a subshell with lower values of n plus L has lower energy. In case 2, subshell has equal value of n plus L. The subshell with lower value of n has lower energy. Pauli's exclusion principle. No two electrons in an atom can have all the four quantum numbers same. It can also be stated as an orbital can have maximum 2 electrons and they must be of opposite spin quantum numbers. Aufbau principle. Electrons are filled in various orbitals in the increasing order of their energies, that is, orbital having lowest energy will be filled first and the orbital having highest energy will be filled last. Increasing energy of atomic orbitals for multi-electron atoms is 1s 2s 2p, 3s 3p 4s, 3d 4p 5s, 4d 5p 6s, 4f 5d 6p 7s. Hund's rule of maximum multiplicity. No electron pairing takes place in p, d and f orbitals until each orbital in the given subshell contains one electron. Example, and nitrogen has 7 electronic configuration. 1s square, 2s square, 2p1, 2p1, 2p1. According 1s2, 2s2, 2p3. That's how. According to Hund's rule and not 1s square, 2s square, 1s2, 2p2, 2s2, 2p2, 2p1. हाँ बता रहा है ऐसे नहीं कर सकते हम. The valence electronic configuration of Cr and Cu, chromium and copper, right? Therefore are 3d5, 4s1 and 3d10, 4s1 respectively and not 3d4, 4s2 and 3d9, 4s2. It has been found that there is extra stability of completely filled and half-filled subshells associated with these electronic configurations. 3 orbitals of 2p subshell, 2px, 2py and 2pz orbitals. Oh, this is diagram of electron cloud, I think. 3D शब्द 3dxy, 3dyz, 3dzx, zx, 3dx square minus y square and 3dx square orbitals. The orbitals. Exam the best.